So assignment related to alcohols and halogen alkanes. The first 19 questions I have solved, so I will start with question 20. So this is question 20, and this question is about the alcohols. There are two alcohol structural isomers with a molecular formula of C3H8O. Give a skeletal formula. So we have to draw a skeletal formula. Skeletal formula we represent either the functional groups or the carbon chains. We don't represent the hydrogens in the skeletal formula. So we have to draw a skeletal formula of these isomers, their systematic names, and the classification, like whether it is a primary alcohol or a secondary alcohol, or it can be a tertiary alcohol. So three carbon atoms are there. We have three carbon atom, and so what might happen, like 1, 2, 3 carbon, and then it's an alcohol, so OH might be attached with the first one. So if the OH is attached with the first one, what we can say, because of three carbon atoms, we can use a prefix prop. They have a single bond, and the first position we have OH, so we can say propan 1-ol, or you can also say propanol. It does not make difference, because when the functional group is attached with the first carbon, then it's not necessary that you position. You can just write propanol. Then what is the classification? Whether it's a primary, secondary, or a tertiary. So how to identify the carbon which is attached with the alcohol? This is a carbon which is attached with the alcohol. It has only one carbon chain. So then it will be primary. To draw the second isomer, so what we can have 1, 2, and 3, and then OH might be attached with the second one. So what is the structure? 3 carbon prop. They have a single bond and the second position we have alcohol, so it will be propane 2-ol. And what is the class of this? Because the carbon which is attached with OH is having 2 carbon chains. 2 carbon chains are there, so then it will be a secondary. If the 3 carbon chains were there, then it will be tertiary. So this is the skeletal formula. Skeletal formula, we don't represent the hydrogen atoms. We just represent the functional groups and the carbon chain. The next question, ethanol can be oxidized by acidified sodium dichromate 6 to ethanol and then to ethanoic acid. The apparatus may be set up in 2 ways. So first one is for complete oxidation. If we have a primary alcohol and we want to form a carboxylic acid, we use a reflux apparatus. But if we want a partial oxidation, like we want to convert a primary alcohol to an aldehyde, we can use the distillation apparatus, as you can see here. The two apparatuses are given. Complete an ionic half equation for reduction of a dichromate 6 ions to chromium 3. State symbols are not required. First, dichromate ions are converted into chromium 3, so chromium plus 3. And how many should be there? 2 should be there, so we'll write 2. How to complete a redox equation? For a redox equation, if we want to balance oxygen, how oxygen can be balanced? By adding a water molecule. So we have 7 oxygen on our left hand side. So how many water molecule we need on the right hand side? We need 7 water molecules. So for a redox equation, when you're completing a redox ionic half equation, if you want to balance oxygen, add the water molecule, same number of the water molecules. So we'll add 7 water molecules. Then if you want to balance the hydrogen, you will add protons. So here, how many hydrogen are there? 7 multiplied by 2 makes 14. So we need 14 hydrogen. So we'll put 14. So hydrogen is balanced as well. Then to balance the charge, what we do, we add electron. What is the net charge on the left-hand side of this equation? We have -2 here and 14 plus 14. So -2 plus 14 means this will make plus 12. The net charge on the left-hand side. What is the net charge on the right-hand side? 2 multiplied by 3 makes 6. And the water is neutral. So it is plus 6 on the right and it is plus 12 on the left. So the side where we have a greater charge, that side we can reduce the charge. So we have plus 12. So plus 12 we can reduce to plus 6. So how plus 12 can be reduced to plus 6? By adding how many electrons? So we should add 6 electrons because each electron is -1. So 6 electron will be -6. That's why plus 12 minus 6, the net charge on the left hand side will be plus 6 and the net charge on the right hand side will be plus 6 as well. Is it clear? This ionic half equation for the reduction. Any doubt in this? Then describe how reflux apparatus ensure that ethanol initially produces further oxidized to ethanoic acid. So how a reflux condenser makes sure that ethanol, because first primary alcohol will oxidize to carboxylic acid, and then from first primary alcohol oxidize to aldehyde, and aldehyde will oxidize to carboxylic acid. So how it can make sure that all the ethanol is converted into carboxylic acid? So as a result, what will happen? Any ethanol which is produced or evaporated will condense back into a flask and it will be further oxidized. So the ethanol vapors condense and further oxidized into the flask. The distillation apparatus effectively separate the ethanol from ethanol because of a large difference in the boiling point, which is a result of a hydrogen bond between the molecule of ethanol. Draw a hydrogen bond between the two molecules of ethanol, clearly indicate any relevant dipoles and the lone pairs of electron, label the bond angle of a hydrogen involved in a hydrogen bond and give its value. Remember, whenever there is a hydrogen bond, the bond angle is always 180 degrees. That's like because it's a linear is there, so it is always 180. How we represent the hydrogen bond, like and between the two molecules of ethanol. So we have example, this is one molecule CH3, CH2, O, oxygen is having two lone pair and then H is there. And then another molecule of ethanol, but this hydrogen is attracted towards the lone pair, like say this is another molecule CH3, CH2, O, NH. So how we represent, because this oxygen will be partial negative. These are the two molecules of ethanol. Oxygen is partial negative, hydrogen is partial positive. This is partial positive, this is partial negative. There is an attraction between them. There is an attraction between the hydrogen and the lone pair. And this is called a hydrogen bond. And what about the bond angle? Because hydrogen, it's like two bonds are formed. and there is no two bond, like a pair to be have two bonded pair and no lone pair. So what is the bond angle? It is always 180 degrees. So this is a hydrogen bond. The polarities are there and the bond angle is 180 degrees. Because a hydrogen bond is formed when a hydrogen is bonded with the most electronegative element such as oxygen, nitrogen or fluorine, and the attraction of a hydrogen is towards the lone pair. Yeah, other will also form a hydrogen bond, but we have to show only for one. This one will also form a hydrogen bond. It may form with the same molecule and it may form with the other molecule as well. It's not, it may have attraction in this way, but maybe a nearby another molecule, it will form a hydrogen bond with that molecule as well. But not the hydrogen attached with the carbon. They cannot form a hydrogen bond because the condition for forming a hydrogen bond, the hydrogen must be attached with the most electronegative element such as nitrogen, oxygen or fluorine. Explain why hydrogen bond do not form between ethanol molecule. So why because hydrogen bonds can, as I mentioned, in ethanol, hydrogen is not bonded to oxygen or nitrogen or any more electronegative element. So why in ethanol? Because this is a structure of ethanol. Ethanol is CH3, C double bonded with ONH. This is ethanol. In ethanol, hydrogen is not bonded directly to oxygen. Hydrogen is bonded with carbon. Or we can also say hydrogen is not bonded with oxygen, fluorine, or nitrogen. That's why there is no hydrogen bond in ethanol. Even ethanol, fluorine, and nitrogen are not there. But if we, the hydrogen bonds are possible if there is oxygen, if there is fluorine and nitrogen. So even in ethanol, we can say like hydrogen is not bonded with oxygen. That's fine. Or you can also list the three elements which result in a formation of a hydrogen. Like whenever hydrogen bonded with any of these elements, it will form a hydrogen bond. Otherwise, it does not form any hydrogen bond. Alcohols can be converted into halogen alkane. Write an equation for the PCl5 reaction with methanol. So this is also a test for checking the presence of OH group in alcohol and in carboxylic acid. So if we have methanol reacted with PCl5, so first Cl will take position of OH. So it will form CH3Cl plus POCl3, the oxygen combined with phosphorus, and plus HCl. So as a result, it will give a misty. State the experimental observation for this reaction. Because of this hydrogen chloride, what we'll observe, always observe a misty fumes. Hydrogen halides, even it's not like hydrogen chloride, even if it is hydrogen bromide or hydrogen iodide, it will result in a misty fumes. Chloroethane can be formed, uh, chloroethane can be made from a mixture of ethanol and potassium chloride and concentrated sulfuric acid. Why chloroethane can be made in this way, but iodoethane cannot be made by a similar mixture? Potassium iodide instead of potassium chloride. You may use equation to support explanation. What actually happened, because when hydrogen halides are formed, these hydrogen halides like hydrogen chloride, bromide or iodide, so hydrogen chloride cannot oxidize because chlorine is not a good reducing agent. It will not reduce the sulfur +6 to lower oxidation number. But in case of iodine, if iodine is produced, it will reduce the sulfur to lower oxidation number as it is a good reducing agent, and it will produce sulfur dioxide, hydrogen sulfide, and sulfur. So if you want a chloroethane, it can be made from a mixture of ethanol potassium chloride. So when first potassium chloride react with sulfuric acid. So as a result, the first one, it will produce potassium hydrogen sulfate. This is called acid-base reaction plus HCl. And this HCl which is produced will not react further. So this HCl will react with ethanol, which is C2H5OH, reacted with HCl. As a result, it will produce C2H5Cl, chloroethane plus water will be there. But what is the disadvantage if you use the same method? Like example, if you use a potassium iodide and sulfuric acid, first there will be acid-base reaction. It will produce potassium hydrogen sulfate plus hydrogen iodide. But this hydrogen iodine is a good reducing agent. So when it will react, it will produce iodine molecule plus it may reduce the sulfur to lower oxidation states, such as it might produce sulfur dioxide, or it may produce hydrogen sulfide. So you can mention these points, like chloride ion is not a good oxidizing agent, reducing agent. So iodide ion is good reducing agent. So as a result, it will reduce the sulfur in sulfuric acid to lower oxidation number. So hydrogen iodide will not be available to react with ethanol. This is a similar question. It is there in group 7 questions, like why iodide ion is a good reducing agent or experimental evidence. So this is always the case. Alcohols can be produced from a reaction of halogen alkane with aqueous. So whenever aqueous is there, it will be a substitution reaction. And substitution reaction as SN reaction can be SN1, it can be SN2. If we have a primary halogen alkane, then it will be SN1. If we have a secondary halogen alkane, then it will be SN2. So draw the mechanism for this reaction. First, we have one bromopropane. So if we have one bromopropane, like first position of bromine is attached. So we have CH2, CH2, CH3, and then one bromo. So bromine is attached with the first. Now, because this is a primary halogen alkane, how it is primary? Because a hydrogen bonded with carbon bonded with halogen is surrounded by only one carbon chain. So this is a primary. So if it's a primary, it will be SN2. In SN2, what will happen? The bond breaking and the bond forming will take place at the same time. So the best way to draw this, you have Br. Here it is attached hydrogen, and then CH2, and then CH3. Halogens are more electronegative, so there will be partial negative and partial positive. And what will happen? Attacking nucleophile is there. Oxygen with a negative charge, so it will attack on the positive center. And then this is the first. Then in an intermediate, what will happen? Bond breaking and bond forming will take place at the same time. How we represent the bond breaking and the bond forming is taking place at the same time. We represent by a dotted line. So dotted line for bromine and dotted line for OH. And the intermediate will have a negative charge because the OH is negative, so intermediate will be negative. And then what will happen? The bromine will break the bond and hydroxide will form a bond. So it will produce H, CH2, CH3, OH is there, plus Br minus. And this bromide ion will combine with the alkali like potassium hydroxide. So it will result in a formation of potassium bromide. So first thing you have to recognize, like from the shape, that which halogen alkane is a primary or tertiary. If it is a primary, SN2. If it was a tertiary, secondary can be SN2 or SN1. So, but always tertiary, it will always be SN1. the reaction with 1 bromopropane with concentrated alcoholic. So now we are using an alcoholic. If we use an alcoholic potassium like alkali, then elimination reaction happen. So name the type of a reaction. So it will be elimination. And displayed formula, in a displayed formula, we should represent all the atoms and all the bonds. So if we were having 1 bromo, like first I'm drawing 1 bromopropane. This was one bromopropane. Now what will happen? In an elimination reaction, the halogen is removed and the adjacent carbon, which is having a hydrogen, will be removed and there will be a double bond. So as a result, due to elimination, it will produce an alkene. So C, H, H, double bond C, H, C, H, 3. How would you test for OH in 2-methyl propane to all without using phosphorus 5 chloride? And name the reagent and state the observation. Other than, because as I mentioned, PCl5 is a test to check the presence of OH in both alcohols and carboxylic acid. Other than alcohol, other than PCl5, how we can test the presence of OH group? So we can add a sodium metal. If we add a sodium metal, it will give fizz effervescence. And if we evaporate all of the liquid, then it will left behind a white solid. Or because it's an alcohol, so you can it will form an ester. So if we add a carboxylic acid and a sulfuric acid, because sulfuric acid is a catalyst for the esterification, so it will form an ester and it will make a fruity, like it will have a sweet or a fruity smell of ester. So name the reagent. We can add sodium and we'll observe fizz, bubbles, effervescence. And if we evaporate the mixture, because it will left behind the white solid. In question 21, this question is about 2 isomeric alcohol and 2 isomeric carbonyl compounds. Which of these compounds would not produce a color change when heated with acidified potassium dichromate 6? Means which of the compound cannot be oxidized? Primary alcohol can be oxidized, secondary alcohol can be oxidized, aldehyde can be oxidized, but ketones cannot be oxidized, or tertiary alcohol cannot be oxidized. So this will be oxidized, it will show a color change. This is a secondary alcohol, will oxidize, like turn into ketone. Propanol will oxidize to propanoic acid, but propanol ketone cannot be oxidized. Which pair of a compound do you expect to have a single charge peak, the mass to charge peak in a mass spectrum of mass to charge 29 in their mass spectrum? This is related to the part mechanisms. That is our next topic. We will discuss there. But the correct answer for this one is propanol and propanol. But how it is done, that we'll discuss in the mechanism, like the mechanism and analysis, the last topic of Unit 2. Which compound you expect the same reason? So we'll move on to the next question.